Hello my dear students. So today we will be discussing the top and very important PYQs of chemical bonding. So when you consider chemical bonding, one of the very important topic for JEE, NEET, EAP set and whatever the all other competitive exams that you are going to attempt on your +2 level right now. Yeah. So you should not skip this topic at any cost. And you know, I have covered complete chemical bonding and what are the important topics included in this. Those things I have covered in this channel. You just go through this channel playlist and watch chemical bonding, like molecular orbital theory, detailed discussion is there, okay. And you know, valence shell electron pair repulsion theory, detailed discussion is mentioned, and all other topics that must be focused from this topic were discussed, okay. So just go to the playlist of this channel and watch. And in this particular video I am going to discuss the PYQs, the very important PYQs or important models of questions that should be focused from this chemical bonding, okay. So now tell me, what are the topics that should be must studied from chemical bonding? First have some idea over topics or the concepts that must be studied from this chapter. So first one is knowing about types of bonds, okay, like ionic bond, covalent bond, that is there now, that is a basic thing. After knowing that, you need to know what is a covalent character in ionic compounds, that is explained by Fazan's rules, okay. So this is a small and very important topic, Fazan's rules, okay. Should not leave this topic at any cost. And after this you need to know about next what we have. Next we have hybridization concept now, valence shell electron pair repulsion theory, okay. This thing should not be skipped, okay. After this you should focus on molecular orbital theory. These are very important topics, that's why I am highlighting those. I am going to solve the questions also, just hold on. I want to give you clear cut idea on these important topics. After this you need to know some other topics like formal charge, okay. These are basic topics, and along with this you need to know like Lewis we have now like Lewis concept, octet rule, okay. So you just need to focus on that octet rule idea, Lewis dot structures, okay. And after this, these are basic things, that's why I mentioned like this. And along with this you need to know resonance. What is this? Resonance, concept of resonance, okay. And along with this you need to know how many resonating structures, concept around this resonance you should know, okay. And along with this you need to know hydrogen bonding and applications of hydrogen bonding, very important, put 2 star marks for that. And along with that you need to know dipole moment concept, dipole moment. I will show you the PYQs of JEE and NEET, just hold for some time on this topic, dipole moment, okay. So these are the very important topic that must be studied by every aspirant, okay. So yeah, so let's begin the session with numericals first, like PYQs first. See, first topic what I mentioned, Fazan's rules now. So based on that you can able to answer this question very easily, okay. Yeah, so I will show you 2 questions on this. Look at this. First question related to this topic is the greater covalent character for an ionic compound will be obtained when. See, for example, we know NaCl is an ionic compound as well as KCl is also ionic compound right now. So but all the ionic compounds, every ionic compound will have some covalent nature, okay. What I am saying, no ionic compound is 100% ionic, there will be some covalent nature. Hope it is clear. So this is also have some covalent nature, this is also have some covalent nature. Out of these two, which is having relatively more covalent nature out of these two? How can we decide? That is explained from this Fazan's rules. What I am saying, Fazan's rule. What he says is, consider what is the cation here, Na plus, anion is Cl minus. Here K plus, anion is Cl minus, right now. So now you need to look for these conditions. There are 5 conditions should be focused here. 5 conditions should be focused here. What is the first condition? With respect to cation, The condition number 1 is small size cation, small size cation, okay, and more positive charge on the cation. This is with respect to cation, and with respect to anion is large size anion and more negative charge. Here more positive charge, in case of cation here more negative charge. Okay, so these 4 condition results to show that particular ionic compound to have some more covalent nature, If these conditions are there for particular species, then that compound will be more covalent when I compare with the other. Okay, so now look at here. So what are the conditions? See, anions are same here, so we cannot answer with respect to anion in this case, but sodium ion, potassium ion, which is smaller in size. Sodium ion is smaller in size now, like lithium, sodium, potassium we are writing. So down the group elements, what happens to the size? Increases now. So potassium ion is larger than sodium ion, right now. So cation with a smaller size has more polarizing power. The compound resulting from that will be more covalent in nature. Since it is small size cation, therefore this will be having more covalent character when I compare with this. Okay, the covalent character of NaCl is more. Hope this is clear. Based on this, you should answer the previous question. Okay, so what are the conditions? Correct conditions are to show greater covalent nature, small size of cation should be there, and they are saying large size of cation. No, this is incorrect now. Both A, B, no, that is not possible. Next, small size anion, no, large size anion should be there, so this is also incorrect. Only first option is perfectly correct for this question, right? Yeah. So let me show you the first question that I asked you. Yeah, look at this, very important. It is a PYQ question. So just try to answer KF, Ki. So out of these two, order of covalent nature, tell me. So potassium, cations are same, anion is here iodide, here fluoride. So which is larger size? Iodide ion is larger now. So large size anion, small size cation, resultant molecule will be having more covalent character. So out of these two, Ki will be having more covalent. So I am writing covalent character of Ki is greater than Kf. So write this. Okay. After this, what we have between Li and F, lithium fluoride and potassium fluoride. So with respect to cation we should answer, because fluoride ions, anions are same here. So your answer should be with respect to cation. So small size cation is lithium fluoride. So covalent nature of lithium fluoride is more than potassium, like this. So this option 1 is incorrect. This is not the correct order of covalent bond. Okay, so remove that. Second option you can see, Ki is greater than this. Yes, this is correct. Li, lithium fluoride is greater than this. This is perfectly correct. Yeah. Next, look at here. So cation is like here Sn is given, tin is given. So +4 oxidation state, +2 oxidation state. What I told you, small size cation and also with more positive charge on cation and with more negative charge on anion will results to show more covalent nature. No? So here more positive charge, +4, +2. Therefore it is having more covalent nature. This is correct up to here. And here when you have sodium and a copper, both are with +1 oxidation state, but this is transition metal like D block element here. This is normal alkali metals. So when we have like this cations with same positive charge, same charge, so you should consider the one which is having 18 electron rule, I mean pseudo inert gas configuration will be having more polarizing power. Okay, so this cation is having more polarizing power, so it will be more covalent when I compare with this. Okay, this order is also perfectly correct. BC is correct. Then next here they are saying LIF, this one. So this is okay, but this is not correct. So this option is incorrect. This is reverse of above explanation. Okay, and here this is okay. Kf and see Ki is more, we discussed already, this is correct. And copper chloride is like CuCl is more than this NaCl. So this is also correct. So A, B, C, E are the perfect answers for this. So option third one will be perfectly matching this. B, C are only correct options from the given 4, 5. Okay, next. Hope you got clarity over this topic, Poisson's rules. Only 5 rules you should remember that we discussed here. Okay, next here. Students, here look at this number of compounds. Next I told you now dipole moment is very very important. I will show you two questions, one for me, one for you as a homework. Okay, now look at this, compounds with zero dipole moment. See, given molecules are HF, H2, H2S, like this they mention. No? So look at here, first one is, what is dipole moment? It is product of charge into distance. Okay, so now here how can we say charge? H, F, these are there now. So partial positive charge on hydrogen, negative charge on fluorine, right now. So we have polarities, therefore this is like having poles now. So what I can say, it is a polar molecule, so it has some non-zero dipole moment. So mu not equals to 0. They are saying mu should be equals to 0. When both atoms are same, for example fluorine is there, so here there is no polarities now, so for this mu equals to 0. So what you can remember, for all homodiatomic molecules dipole moment will be 0. For all heterodiatomic molecules dipole moment will be non-zero. So example here, for this first option it is non-zero, it is not equals to 0, and this is equals to 0. Okay, and because H2 is a homodiatomic now, H2 equals to 0. For H2S it is having bent shape now. See, sulfur, one hydrogen, other hydrogen, lone pairs here, lone pairs here. See, lone pairs are there now, and which is more electronegative? Sulfur here. The net dipole moment will be towards upside. So mu not equals to 0 in H2S. Again see, CO2 is there. What is the structure of CO2? sp hybridization, right? So like this. Okay, so dipole moment will be cancel out each other like this whenever you have linear structure with the same side atoms with zero unpaired electrons on it, or non-bonding electrons on central atom. Okay, it will be mu equals to 0. Okay, this will be equals to 0. And for ammonia, what is the hybridization? sp3. sp3 hybridization with one lone pair we have right now. So lone pair will drag upside, and nitrogen hydrogen, which is electronegative, nitrogen now. So that there will be bond polarities like nitrogen, hydrogen, hydrogen, hydrogen. If I write, lone pairs are here. See, out of these two, nitrogen and hydrogen, nitrogen is electronegative, so dipole is moving towards upside, and lone pair are also upside. So overall dipole moment, net dipole moment is moving one side only, right now above side. Therefore mu not equals to 0 in this case. Okay, like this you need to verify for all the options. Okay, see BF3, first find its hybridization. Hybridization for BF3 is sp2. I will explain this. sp2. sp2 means 3 hybrid orbitals are there now. So 3 hybrid orbitals, 3 surrounding atoms, right? There means there is no non-bonding electrons around the boron here. Only fluorine atoms are there. So now look at here. It is having angle of 120. Now fluorine, this fluorine drags this side, and this fluorine drags towards this side, and here also this side. The mu resultant of these fluorines will be like this, exactly opposite of the other fluorine. Okay, therefore they will cancel out each other because dipole moment is a vector quantity. Its dipole moment will be 0. See, whenever you have a center atom with a regular geometry, for example carbon hybridization is sp3. For sp3 we know geometry will be tetrahedral right now. So for tetrahedral, 4 surrounding atoms, all 4 surrounding atoms are same with 0 unpaired electrons on central atom. Okay, so you can say this is regular geometry with symmetric around the central atom. Therefore its magnetic dipole moment will be 0. Okay, hope this is clear. For example PCl5, if we consider PCl5, what you will get? Trigonal bipyramidal geometry. So all the surrounding atoms are same, and there is no lone pair electrons on central atom right now. Therefore it is having symmetry around the central atom with regular geometry right now. So mu will be, dipole moment will be equals to 0 for it. Okay, yeah. So for chloroform, you tell me chloroform. So how it is? Chlorine here, again chlorine here, hydrogens here. See, dipole moment is downside, so mu not equals to 0 in this case. And for SiF4, silicon tetrafluoride. Yes, whatever story I told you for methane applicable here, because silicon also tetravalent belongs to carbon family, right now. Therefore all surrounding atoms are same with sp3 hybridization for silicon. So surrounding atoms are same means it will be 0. Mu equals to 0 for this symmetry. Okay, next term. For water molecule, same story as H2S. It is bent having lone pair electrons, mu not equals to 0. So for B is F2. What is the hybridization? Find hybridization of central atom. Group 2 element now. So 2 plus surrounding atoms 2. 2 plus 2 4 by 2. So you got 2 as a hybridized orbitals. Hybridization is 2 means sp. So sp means linear now. So write beryllium in the center and this side one fluorine, this side another fluorine, exactly opposite 180 degrees. So if they are opposite and they are having same bonds connection, so it means dipole moment cancel out each other, mu equals to 0 in this case, mu equals to 0 in this case. They are saying 0 dipole moment. So how many 0? So 1, 2, 3, 4, 5, 6. So your answer should be 6. Okay, if you are clear with the dipole moment, you will definitely expect a question from this topic. So make it more clear by studying it properly. Okay, next. Okay, so we'll come to this. Yeah, so look at here, based on dipole moment again, I have one more question. Assertion reason based question. Again, this is also PYQ of 2024. Okay, so look at here. What they are saying, given two statements, assertion reason. Assertion is ammonia and NF3. So NH3 and NF3 are given. Okay, I am writing those. NH3 means you should write the structure as H like this, like a pyramidal geometry. Okay, and along with that you have NF3. So NF like this. Okay, with pyramidal geometry, both of them. But here, you know, lone pair electrons upside here, so that will drag always upside towards it. But you know, bonded atoms between nitrogen and hydrogen, which is electronegative, nitrogen now, so dipole moment is towards nitrogen like this. But here fluorine is more electronegative than nitrogen, therefore dipole moment will be in opposite direction like this. Okay, yeah. So now tell me, net dipole moment in ammonia will be completely upside. So mu net of ammonia will be greater than mu net dipole moment of NF3. Why? Because this is going opposite direction. For lone pairs above side, for fluorine atoms downside. So they are cancelling out to some extent. Therefore NF3 dipole moment is less than NH3. Like this you should write. Okay? Yeah. So now look at this statement. NF3 and NH3 molecules have pyramidal shape, yes, and with a lone pair electron on nitrogen, yes, that is also perfect. The resultant dipole moment of NH3 is greater than NF3, yes. I explained now, NH3 is greater than NF3. This is assertion is okay. We can able to understand that. And ammonia, in ammonia, reason for this explanation they are saying, this assertion they are saying like this. In ammonia, the orbital dipole moment due to lone pairs is in the same direction as the resultant dipole moment of NH. See, all of them are in the same direction in NH3 case, above side, right now. So mu net is directing towards above side only in ammonia, but not in case of this NF3. Not in case of NF3. This is the reason now. So assertion, reason, both are correct, and reason is correct explanation of assertion right now. So you can go with option number 1 as your answer. Hope this is clear. Yeah. So if there is any doubt, just feel free to express in the chat box very clearly so that I will address that. Okay? Yeah. Next question here. This is again on molecular orbital theory. We will come back to this once we will solve these hybridization questions. So look at here. In the last question I have explained you about dipole moment. Now again same dipole moment question is there here. I am expecting answer for this question from your side. So I want answer for this question, dipole moment question from your side. Hope you got my explanation in the previous question. follow the same thing and tell me answer for this one. Okay, now I am going for solving this question. See, list 1, list 2 are given. Okay, we need to match them. See, both questions are 2024 questions only. Very, very important topics these are. Okay, look at here. How do you do for ICL? What is the central atom? The larger size atom is considered as central atom in this case. In case of interhalogen compounds, if both are halogens, consider the large size large size halogen as the central atom. Okay, so halogen. So just follow this simple one. ICL is given, central atom is halogen. What is the group number of central atom? 17. So 17 minus 10. So you have 7 electrons in the valency of this halogen. Right now, put that 7 electrons like this, dots, 7 dots. So 3 over 4 plus 3, 7 over. So 1 ICL, like this, 1 is paired up and remaining 1, 2, 3. So 1 is sigma bond formed with the chlorine and remaining are lone pairs on the iodine. So you can get a structure like this, ICL, like this. Okay, so how it is? Like a line now. So you should say it as linear. What is that? Linear. A4. So your A is 4. So A4 in these two options, remove first two. Next, ICL3, apply same concept for this question also. What I told you? How many electrons in the iodine? 7 electrons now. 1, 2, 3, 4, 5, 6, 7. Okay, 3 chlorines are there. Each chlorine form 1 bond. So like this, 3 bonds over. So this is one set, this is second set. So what you are going to get here? So 3 sigma bonds plus 2 lone pairs. So 2 lone pairs, 3 sigma bonds plus 3 lone pairs, total 5 now. So 5 hybrid orbitals you are going to get. S, P3s are there and 1 is D. So 1 S, 3 P's, 1 D. Total number is how much? S1, P3, D1. So 5 now, 1 plus 3 plus 1 is 5, like that. Okay, right. So you got sp3d hybridization with 3 sigma bonds, 2 lone pairs. So with sp3d hybridization, the geometry is considered as the geometry with sp3d hybridization. You will get trigonal bipyramidal geometry. It means what? Put the central atom around that, arrange like this. Okay, so this is a trigonal bipyramidal, one above, one below. Okay, like this. And you know, these yellow color lines you are seeing here. So these are having 120 degrees angle, and this pink color above and below are called axial lines having 90 degrees here, right now. So now always remember, lone pairs will experience more repulsions. So in order to avoid that repulsions, you need to place these lone pairs in the equatorial position. Why in equatorial and why in these yellow lines? Yellow lines are called equatorial lines here. Why in this position? Because in order to avoid that repulsions, we need to place them with maximum angle. Maximum angle is here 120, here 90. So 120 is better now, maximum angle. So place your lone pairs. How many are there? 2 lone pairs now. Here 1 lone pair and here 1 lone pair, like this. Okay, remaining 3 atoms in remaining positions. Here 1 chlorine, second chlorine, third chlorine. So how is the structure now? Look at the structure, how it is looking. Iodine in the center, chlorine here, 1 more here and 1 more here, with 1 lone pair here, 1 lone pair here. So something like a T shape, something like, see, this is like a T now. Yes. So what is the shape of this ICL3? It is T shape. So B1. So B1. Yes, we directly got our answer. C, option C is our perfect answer for this question. If you want, you can verify for other questions also. See, other also interhalogen compounds. So ClF5 is given. So tell me what I told you. Group number of central atom is 17. 17 minus 10, 7 electrons. Okay, 7 plus surrounding atoms are 5 plus 5. 12 by 2, you will get 6. So 6 means what is the hybridization? sp3d2 hybridization. If it is sp3d2 hybridization, your geometry should be octahedral. If it is octahedral, how do you draw that? You should take central atom here like this. Around that, make a square like this, square first. On the square, you put 1 above the square, 1 above the square, 1 below the square. The resulting geometry is called octahedral geometry. Now, in this octahedral geometry, we require 6 atoms around the central atom, right? Now 6 positions are there, but here we have only 5 atoms. It means the sixth position is occupied by lone pair electrons. Always remember again, lone pair should be placed either above or below this square. Okay, here I am placing lone pairs, and remaining 5 positions I can place fluorines like this, like this. Okay, I hope it is clear. Now see how the structure is looking, square with one pyramid on it, like this. If I join all these things, so we'll get a square pyramidal geometry like this. Okay, we'll get a square pyramidal. So what is this? ClF5 is square pyramidal, and this IF7 will be pentagonal bipyramidal. Hope this is clear, right? Okay, so option C will be perfect one. So based on my discussion or explanation of this question, I am expecting answer from other questions here. See, yeah. So I just want an answer for this question. See, this is a NEET 2018 question. I want answer for this question. Tell me, structure of ClF3, the number of lone pair electrons on the central atom, the central chlorine atom. Very easy. We discussed. Apply the same concept for this. Even I have discussed same question there. You can use that and answer this in the comment box. I am looking into the chat box. Even if it is online, those who are watching it live, you can answer it, and even if someone are watching after this live session, can answer in the chat box. I will look into it later also. I will guide them if there is any mistake in that. Okay, yes. Next we'll discuss about molecular orbital theory here. See, the question says order of stability of these given molecules, compounds. For O2, how many electrons are there? Oxygen, 8, total 16 electrons now. So write 16 electrons in their respective atomic orbitals. So for oxygen, 1s2, 2s2, 2p4 we have now for same both of them. So when oneness of both atoms combined, we'll get, when two atomic orbitals are combining, we'll get two molecular orbitals. One is bonding, another one is anti-bonding. Okay, so anti-bonding I represent with star, bonding I represent normally. So they form sigma bond when they one is combined. So we'll get one sigma 1s, sigma star 1s, and 2s, sigma 2s, sigma star 2s. Like this, when p orbitals combine, we'll get sigma 2pz and sigma star 2pz. Next, after formation of sigma, we'll be having pi. Okay, I will tell you the trick also. Just listen to this concept first. Okay, next we will be getting 2px equals to 2py. Next, bonding we have written now respect to anti-bondings, pi star 2pz, x equals to pi star 2py, and next sigma star 2pz. So if you are not aware of this molecular orbital theory, just watch my video, a special session made on molecular orbital theory. Almost like 45 minutes will be there. Once if you watch it, you will get complete idea on molecular orbital theory. Okay, just go through the playlist and watch it. Okay, now tell me what I can make here. It will be like this now. So fill, how many electrons are there? 16 now. 2, 2, 2, 2, 8 over 9, 10, 11, 12, 13, 14, 15, 16. So 16 electrons are there. So find the bond order for this. Half into number of bonding electrons will be 10. Count 2, 4, 6, 8, 10. 10 anti-bonding are 2, 4, 5, 6 like that. Okay, so 10 minus 6, 4 by 2. So bond order is 2. When you have 16 electrons, so for O2 16 electrons now, so bond order is 2 we got here. Okay, if it is O2 minus 17th electron, again and going to anti-bonding. So anti-bonding electrons are increasing now. So it becomes 10 minus 7. It will be 3 by 2. It means 1.5 here you will get. Okay, use this trick I will tell you. So it is 1.5. Like this you find bond order. So if you get 18 electrons, okay, decrease by half. 18 electrons decrease by half, it becomes 1.0. Again, O2 plus 15 electrons. Even if I remove one electron, that is going from this anti-bonding now. So it means it becomes 2.5. So remember here one small trick. 14 electrons, bond order 3, 15 electrons, bond order 2.5, 16 electrons, bond order 2.0, and 13 electrons 2.5, 12 electrons 2.0, like this, 17 electrons 1.5. Just for every increase in 1 electron, decrease the bond order by 0.5. For every decrease in bond electrons by 1 electron, decrease bond order by 0.5. That's it. That's it. This is a simple trick. Now tell me, what is the bond order for this? Like this we got now. So bond order directly proportional to, what do we mean by bond order? Number of bonds between two atoms, like this. Number of bonds is 2 now, so 2 like this. So as bond order increases, stability also increases. Okay, stability also increases. Now tell me, which is having more stable out of these two? So O2 plus, bond order is more for it. Then next O2, next O2 minus, least is for O2 2 minus, like this. So fourth option will be your perfect answer for this question. Okay, yes, 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 yes. Okay, now based on this, try to answer my question here. Molecules in the following, identify the ions with the same bond order. So tell me which of them are having same bond order. Cn minus, how many electrons? Cn minus means carbon, 6 plus 7 plus 1. Okay, so 14 electrons, it means bond order will be 3. For 18 electrons, O2 2 minus means 18 electrons, bond order is 1. Okay, so, for this it is 13 electrons are there, 14 means 3, but 13 only, 3, 2.5 for this NO, how many? 7, atomic number 7 means 7 electrons in nitrogen, and oxygen is having 8 electrons, plus 1 means remove 1 electron, therefore 7 plus 7, 14 electrons, bond order is 3.0. So which of them are having same bond order? First one and fourth one. So 1 and 4. So option number C will be your perfect answer for this question, right? Hope it is also clear. Now use the MO theory like orbital diagram and try to answer this question. The compounds contain only pi bonds between the atoms. Okay, so just give a try for this. If you are unable to answer molecular orbital theory question, because you can expect one question from molecular orbital theory and one question from valence shell electron pair repulsion theory in the exam at any cost. Okay, if you are unable to answer that, just watch my video in the playlist molecular orbital theory by Ajay Sir. You can type from NEET World, so you'll definitely get that. You watch it, you'll get clarity over the topic. Okay, yes, try this both questions, and one more here I have one more for you. Try this question also. And here, based on ClF3, I told now it is having T shape, BRFI square pyramidal, I have told you. And if you find for this xenon 18th group now, so 8 plus surrounding atoms 4 by 2, so 12 by 2, 6 means sp3d2. What you are going to get? sp3d2 means octahedral, but here only 4 surrounding atoms out of this 6, so 4 sigma bonds, 2 lone pair electrons. Okay, so in octahedral, above the plane, below the plane you place lone pairs, in the within the plane you place 4 surrounding atoms, fluorines. You will get square planar, so D2. Okay, ClF3 is what? Seesaw. Okay, hope it is clear. So based on this you can answer. Okay, remaining questions we will discuss in the upcoming session. So stay connected with this NEET World channel. Thank you. Stay connected with us.